Welcome back to part 2. In part 1 we covered monitoring frame rates and how that can affect performance, and we added the post-processing stack, added bloom, ambient occlusion, and we made some tonal adjustments. What we're going to look at now is how we can improve performance. So no matter what frame rates you're getting, if you're dipping below that 60 mark, we've got to try and take steps to push it forward. What you will find is when you put the headset on, if you are getting very low frame rates into the 30s or below, you'll start to get this impression that the scene is melting, and that's not something you'll see through the monitor. Other people looking at your game won't see that through the monitor. However, what you will see through the headset is that it looks like it's melting. That's the headset trying to compensate by doing, I think it's like a form of anti-aliasing where it's blending frames together, but it feels very melty and very poor. So you want to try and avoid that at all costs. So managing your frame rates and improving performance is the thing to do. We're going to start with a really simple form of managing both frame rate through RAM utilization and also through what the camera is having to do the work it's having to do. To do this, it's really simple. It's under Window, Rendering and Occlusion Culling. We're going to do some not ambient occlusion, we've done that already, occlusion culling, that's all it's called. So what we've got here is occlusion, and we've got bake, which is a similar button for those who have used light baking, and we're going to come to that a little bit later on, or if you've had to bake your nav meshes if you're doing some AI. What this lets you do is it will divide your scene up into individual chunks, and then unload that data when it's no longer something the scene needs. So with bake on here, I'm just going to press bake. It'll take a minute to divide it up. You can see it's adding some chunks and dividing the scene. It's adding, obviously breaking these things up, and that didn't take very long at all, to be honest. It was actually quite quick. But this will only work if things in your scene are declared static. So you can see there next to the name, static. If it's not static, this won't work because it assumes things will load and unload. So under occlusion, if I now click in the game view or even in the scene, select a camera from the scene. There you go. What this will now do is visualize what we'll be able to see in the game view through the view of the camera. So if I click on cameras here, it gives me a list of cameras. Okay, I was expecting it to have an immediate effect, but what you'll find in your scene is you'll see that it will unload data that you don't see. So that's what the visualization is doing there. So you can see visibility lines at the rays for what the actual camera can see, so it will unload everything that's not there, and portals are the areas are going over areas. The way of thinking about this as well, if you've got a very large GTA map or something like that, that moment where you might get a slight buffer as it's loading from one scene to another, that's occlusion culling coming into effect. It's unloading one area and loading into another, which means it's less intensive work for the computer to do, but the trade-off is you have to pre-process it. So again, with the headset on, you can now see again, we're not going to get more than 72 frames per second because we can't with the monitor that I'm using. It seems to be that's the refresh rate for the monitor. However, you'll see a performance notice if you're below that 72 mark or if you're a little bit lower than that. So that's a thing to keep in mind. If you are anything below 72, you want to be using some of these techniques to try and ramp it up. And if I just do that again, but this time with Task Manager open, what you'll see is the GPU will turn up for work. It'll start working a little bit more. You can see it there in both of those charts. The GPU is working harder, but it's only utilizing 65% of the GPU. I could use more of it if the refresh rate for both the monitor and the headset were higher. It would be able to output that. Now, the reason why I'm a bit confused about refresh rates is it's outputting at 72 frames per second. That's the refresh rate because of VSync. So it's matching the frame rate through VSync. So that's the thing to make sure it's capped at whatever the headset or the monitor can output. The reason why I'm confused is you can turn VSync off. So under Edit and project settings, you have the quality tab here, and in your project you'll find that vsync count will be set to every vblank because I've turned vsync on. I've turned vsync off and I'm still getting that cap, so I don't quite see where the issue is with that. But needless to say, if we're above 60, that's the important thing that we want to be seeing. So that's the notion of occlusion culling. Very, very powerful tool for dividing your scene up. If you do find that it's divided your scene up and it looks like you can't move around your scene anymore, just make sure you're back in the object mode, and that shall put everything back. Or you can just click off of occlusion. Is it occlusion areas? Okay, whatever it's doing, it's done the trick. So let's just close occlusion down there. Next thing's about light baiting. Oh dear, light baiting. I may leave this till last, simply because if it starts taking forever, I want to be able to bin the tutorial at that stage. But let's move on to the next thing, which was about light probes. You can see in this scene, again this is all pre-set up, I've not done any of this work here, you'll see there is an empty game object which contains a series of probes. What these probes are lighting and reflection probes. The way these work, there's a bunch of dots dotted around with lines joining them all up. A probe is probably best demonstrated in our basic scene. There's not a lot going on in here that can confuse us, but you can see there's no probes in this scene. I'm going to create an empty game object and I'm going to call it probes. And in here you can create both lighting and reflection probes, and that is a rendering thing. Is it effects? There you go, it's under light, and you can create a reflection probe or a light probe group. Let's start with light probe. When you pre-calculate your lighting, which we're going to do in a second, you will end up with areas in your scene that are in shadow, in light, and sometimes those lights will be of different colours based on the reflections that have happened and the pre-computation that's happened to your scene. So the idea here is with light baking we will have different areas baked together. Actually, we'll try and do it in this scene because I don't think it will hurt all that much. So let's talk about light baking while we're here. I'm going to select this table and I'm going to tell this table, if I remove the boxes off of it, this table in all its glory is going to be a static object. You can see its shadow down here. Okay, but I'm going to declare it as static. That's telling the engine this object will never move. That means I can't animate it anymore. If I wanted to animate it, the animation won't play. But what I can now do is get away with information about lighting I otherwise didn't have. I've got a spotlight in my scene over here, and I'm going to turn this spotlight, I'm going to put it over here, I'm going to turn it on, and I'm going to make it red. I'm also going to turn shadows on. So what we should hopefully see, I'm going to raise the intensity of this light. You can see its shadow being cast here. The other shadow being cast is coming from the directional light. That's the thing up here that represents your light, your sun in your scene, and you can rotate it, which will change the angle of that. The sky, the sun, should always be either a mixed or a real-time light. That means it will cast real-time shadows. If you're holding an item in your hand, you want its shadow to follow you around and to be done in real time. However, with certain things we can pre-process its lighting, we can bake its lighting, so we don't have to have the computer do it in real time, which really stresses the CPU. The GPU handles a lot of graphics data. However, lighting isn't graphics data. Lighting in most contexts is a general purpose computation, so lighting, particularly shadows, is handled by the CPU. If you have an RTX card or something that handles the real-time ray tracing, which is that big buzzword that no one really knew what it meant, it will do this way quicker than if you're on the machines down Coombswood running the GTX cards before real-time ray tracing was introduced. That's why they rebranded it RTX for ray tracing. But what this will do, because lighting is all about ray tracing, it will cast a series of rays out, spin up the CPU, have it work at full power for a period of time while it pre-calculates your lighting. Also important for this to work is any surface you want your shadows to be baked onto must also be static, otherwise your shadows won't be pre-calculated. This light, I'm going to turn it from a real-time light into a baked light. What I can now do is go to Window, Rendering, Lighting. So useful, I'm going to stick it over it. And with the Environment tab selected, you can now generate your lighting, which will bake it. This is the single biggest thing you can do to your scene to improve your frame rates. If you've got bad frame rates and you've got lots of lights in your scene and they've all got shadows switched on, this is the thing to do. I've got one light which is being computed right now, and it's going to take some time. It's not going to take that long, but it will take a period of time to calculate this one light. And what I'll do is, if I just look at Task Manager over here, you can see my CPU is spinning up because it's a CPU that's doing the hard work here. The GPU hasn't turned up for work today. It's all handled by the CPU, so we're CPU throttled and bounded here. You see it's going to take a few minutes. You can still carry on working. And what you'll notice is that line there, that's where my camera was, it was lined up here, and it always starts calculating lighting based on what you can currently see in the scene. In the case of Coombs Wood, if you do this, your machine is now utterly unusable. It'll spin up the CPU to 100% utilization. You can't do anything with it while it's calculating lighting. Now I've got one light on a powerful machine, well, relatively powerful machine, and it's taking me about, it'll take a couple of minutes for it to finish processing where the shadows are going to be, because it's working out each ray. There's probably 1 million rays coming out from this, bouncing off. What does it hit? What does it illuminate? And you can see it's giving some really nice illumination on the table. You can see where the shadow is being cast. But if I were to, I'm not going to because it's still calculating it, but if I were to grab the table and move it, the shadow wouldn't move with it because it's been pre-calculated. You can also do things in here with the Environment tab, like changing your skybox and changing your fog. If you wanted fog on, that's a property that you can turn on here if you've forgotten where that was. This is going to take a couple of minutes. While that's doing its thing, let's talk about these probes we were speaking about. A probe, if we add it into here, it was under light, and I'm going to add a light probe group. This adds a bunch of dots that you can select and move around. You don't select it by left clicking on them, you select it by clicking on the inspector, and you've got the edit button, just like you've got when you modify a box collider, and then you can select the individual probes. What these do is, if you have an area of light and you have a baked light like we've got here, and we've got a zone of red, any object moving into that zone will not be receiving light because it's a baked light, it's been pre-processed, it won't know it's in that zone. But you add a probe group and it will pass information to whatever 3D object is in that zone, going, hey, you're about to move into an area of red, you should probably start going red now. And you'll find that if you have probes that straddle an area of illumination, so if I've got one probe there and one probe there, let's say, there you go, and you can see that that's just finished baking my lights, and it's created a lot of baking data is what you've got. But if I go back to my lighting groups here, if I then had an object that were to be in that scene, it would be changing and transitioning colour from the regular lighting into red in real time. So let's go and have a look at that. And you can see the light probes in the, this is not in game mode, this is just in the scene. It's highlighting, hey, these are the probes that have influence over this object. And these probes have detected that there's red light around here, it should go red. If I move it out of this zone, hopefully it will get a little bit darker as well. If I put some more probes in, I need some more probes in there because it doesn't know how it works. How do I add a probe? I click add probe, that's how we do it. There we go, and you can add probes and you can add probes. And you can see in that more complex scene, there was lots and lots of data going on over there. So I expected this object to have that Right, now I need to again pre-process my lighting. I think if I generate my lighting, that will also generate data into the light probe group. It shouldn't take as much time this time around. Now you can see there's more light on the right side than there is on the left, hopefully. And as we get closer and closer and closer, it should be picking up more of that red lighting, which it seems to be. And then as we move it through over here, again, because there's no probes over on this side, the closest information it's got is this probe over here, which is within the red zone. So I'd need another probe out here to say you're moving out of this zone. So basically, if you've got areas of colour, you want a probe in there. Now, reflection probes work in a very similar way, but probably outside the scope of what many of you are going to be doing. Lighting, reflection probe. And you can have as many of these as you like again. What these do is they don't handle lighting data. What they handle is reflection data. If you guys have seen the bit of Fallout 4, you know, you've got Mr. Handy's very highly reflective metal object, Mr. Handy, little metal robot thing. When you looked in that shiny surface, you could see the environment reflected in there, but you could never see the character reflected in there. That's because they'd pre-processed the reflection data for the environment it knew it was in, but anything that moves can't be pre-calculated because it's not static. Reflection probes work in a very similar way to light probe groups. You dot a bunch of them around, and if you've got highly reflective surfaces, that data gets baked into the reflection probes. So if I go back to our complex scene, what you will find is in the probes group, I've got a bunch of light probes and a bunch of reflection probes. Now, these haven't yet been pre-processed. If I look at my lighting, I can see that this is a baked light, but it hasn't necessarily been baked for the environment it's currently in. So here's what I'm going to do. I'm going to take a save. This is everything I wanted to cover in today's kind of tutorial. Light baking and light and reflection probes. There's a lot more you can do. Brackeys has got a very good tutorial about it as well, about lighting and how to set it up. And I do have a more in-depth tutorial on Moodle. Complex lighting, if you want to know more about light baking in more detail. But what I'm now going to do is I'm going to press the light bake button in this complex scene, and this may well ruin the recording and take forever. But you can always pause and cancel a bake, and you can always leave it overnight if you're at Coombs. If you're studying on a Monday and you're in on Tuesday, 634, I know that relates to you guys. 632, I know you're at Coombs on a Wednesday, you're in C9, and then you're in C8 on Thursday morning, so you can always leave a bake going overnight. So let's see how long this is going to take to calculate all my lighting in this scene. When I did this on my old computer for this scene, it was about 36 hours. Let's see what it's going to project. And let's also keep an eye on Task Manager and watch my... oh, there we go. Hopefully the recording hasn't gone horribly wrong, but there you go. Maximum CPU. Absolutely tanking my machine. GPU not turning up for work. All happening on the CPU. I just want to see the predicted time, but there is one more thing I'd like to show you if you want to hang around till the end. Or, you know, you can fast forward, that's an option. So you'll notice it's purged all of the previous light data. You can actually see the little pockets of rays striking the surface and being calculated. Excuse me. You can see it's recalculated that lighting, so I set it back to blank and it's redoing it. In the case of this machine, it's going to take under an hour. Again, these predictions vary, and as my CPU is going to start heating up, it's going to start thermal throttling itself, which will take a little bit longer as well. So you can see it was there at around the 4 GHz mark above, and now it's throttling down a little bit, because otherwise it's going to, well, bake, if you'll pardon the pun. And you can see the times going up there as it's thermally throttled itself. But what I'm going to do is stop this, and I'm going to show you one more option that you have if you've got a more powerful GPU than me. So I'm currently running an RTX 3060. I've cancelled that bake halfway through, and you'll see the only bit that it's really processed is the bit that was in the field of view. If I turn around here, it's not really done any work. But in your environment, in your lighting settings, is it in scene? Sorry, in the scene view, by default it uses the CPU, it uses the progressive CPU to process it. You can get it to get the GPU to do it if you have an RTX card. This is still in beta, but it's a thing that you can do. Let's see what this does. Again, I'm going to cancel this, and I'm going to generate the lighting afresh using my GPU. And my GPU will have to turn up for work now. Again, okay, CPU, hard at work. Why? Imagine this worked, but yeah, you can see it's very much still in beta. Now I know that this will work, but it could be because I started it and restarted it, who knows. Force stop, cancel, and I'll just give it one more. Let's clear my baked data, so I just clicked on the drop down and I cleared it. And let's generate the lighting using progressive GPU. No, it's still hitting the CPU. How very interesting. It could be that global illumination has to be processed on the CPU. Who knows? We'll stay watching this for a couple of seconds. If you're bored, you can go. This is literally just me experimenting at this stage. But that's everything we ultimately wanted to cover. Okay, CPU's calming down a bit. Is the GPU going to turn up for work? There we go. Turned up for work briefly. If you listen carefully, you may hear my fans. They have spun up big time. It's not going to take 50 seconds. It's going to take way longer than that. Always assume light baking will take forever. So I'm curious if this is actually going to be a lot quicker. I can't have done it that quickly. Oh my god, RTX, are you... Actual oh my god moment. I think he's done it. In minutes rather than hours. Progressive GPU, you can stay. We need some computers with RTX cards in. Spoiler. Right, that's everything from me, guys. Have yourself a cracking time, and grab me if you need me. Talk to you soon.